What does it mean when we write log without a base? When we write log without a base, we are referring to the common log, or the log base 10. That is, if we just write log x, we mean the log base 10 of x. I should warn you that this is true in most contexts. If you ever find yourself in a context where it's not true, someone will tell you. But if you just see log x with no other information, it means log base 10 of x. Now, why are we mentioning this? If you look at the keys on your calculator, you'll see that one of them, right here, is labeled just log. That key gives you the common log. Why is that nice? Because on every calculator, we can compute the log base 10. We can do it for nice numbers, like 1,000 is 3. But we could have known that without the calculator, right? Why? Well, because 10 to the third is 1,000. In general, if we take the log base 10 of a 1 followed by some number of zeros, it's just the number of zeros, right? But we can also take the log base 10 of a number like 227, which is some horrible decimal. That's to be expected, right? I'm going to round it to 3 decimal places because that looks nice. Did we expect this to be a nice number? Well, no. 227 isn't any nice power of 10. But if we take 10 to the power 2.356, what do we get? Not exactly 227, but really close, right? If we round this even to 2 decimal places, we get 27. This is going to turn out to be handy when we're trying to solve equations that involve exponentials or involve logarithms. I'm going to have you just practice on the calculator for a moment. Use your calculator to find each of these logs. If you have to round to 3 decimal places. Then, write an exponential expression, punch that into your calculator to check. Pause the video and try this now. Alright, so we're going to compute these guys. Log of 100, we just get 2. I don't think that surprises us. Log of 4, that's some horrible decimal. We'll say that's about 0.602. Log of 0.001. Negative 3, we can get a negative number? Oh yeah, the range of the log is all real numbers. And that's exact, we don't need to round. Log of 0.4, oh, another negative number. That's about negative 0.398. And finally, log of 6395. That's about 3.806. We'd like to check these with exponentials. Right, we'd like to say 10 to the 2. Well, we already know that's 100. We don't need the calculator. 10 to the 0.602. We'll see what that works out to. 10 to the negative 3. Maybe you know this one, or maybe you'd like to use the calculator. 10 to the negative 3, negative 0.398. And 10 to the 3.806. Let's put these guys into the calculator. 10 to the 0.602. That's pretty close to 4. 10 to the negative 3. Oh, that's exactly 0.001. 10 to the negative 0.398. Again, that's really close to 0.4. And 10 to the 3.806. That works out to about 63.97. Ooh, 63.95, 63.97. Is this wrong? No. We just have some round off error. If we'd carried more digits in this answer, we would have gotten closer.